Ling and Peter Schneider. This organization is intellectually and building science-wise just the leaders over on the East Coast, and that they've got competition, but they are in terms of their monitoring and their design practices, as well as the all-important question of financing and addressing populations who really need their help. But just on the building science alone, superb. So excited for you guys to talk about how you guys are going about addressing some of the most vulnerable populations and helping them out. Thank you, Ling.
Thanks. So we're, Sean asked us to present a case study of a mobile home replacement. And so all of this beginning part is just pointing toward the story of one particular family. So it's myself, Peter Schneider actually runs the program here and in Vermont, and then also in some of the EIC's other initiatives out of state, out of Vermont. I also support some of the work there as well. So just to ground us all in the terminology, a mobile home is used very universally for this type of housing, but it actually has a specific meaning, which is it's the older type of homes that were built before there was any code covering them at all. So when we are talking about more modern housing like this, we call it manufactured housing. And it still has a chassis under it, but by saying manufactured, what we're saying is that it falls under the HUD code. And you can see that the HUD code doesn't get updated very much. And then what our mobile home replacement effort is using modular homes in place of either mobile or manufactured homes. And modular homes are required to meet the local codes. They sometimes are built out of state, they sometimes are trucked in from quite a long distance, but they don't fall under the HUD code, and so they have to meet the local codes. They're more flexible also in terms of what the house looks like, because you can stick a bunch of modules together in all kinds of configurations. Whereas mobile and manufactured homes just typically look like a single wide or a double wide. And you can see some of them really look like campers. These are really old ones. So the type of places that we're doing mobile home replacement are neighborhoods. This is a neighborhood in Burlington, Vermont, which is Vermont's biggest city. And it's really, oh, sorry, we advanced. There we go. It's really considered like the only affordable, truly affordable housing ownership in the city. The rest of the city is like high real estate pressure. There's lake views, there's a university, there's a lot of student housing, and so the houses are expensive. And this mobile home park, I think, is the oldest mobile home park in the state, and it's really packed in there. Some of the homes are, I don't know, 10 feet apart, maybe 6 feet apart even. So the red boxes there are just vacant lots at the time that this mobile home park went co-op, and it's places where the city was interested in working with us on doing mobile home replacement. And you can see from the picture down below that there's not a lot of space in the mobile home park, but people who live there actually really enjoy the neighborhood, and they're proud to own their home. So some people think of mobile homes as being affordable. And we actually would say that they're different than that. Affordable is not the right word for it. They are cheap, and they sometimes are considered affordable housing. And there are a lot of people that live in mobile home parks. So across the US, more than 6% of the housing stock is mobile or manufactured homes. In Vermont, it's a bit higher. In California, it's a bit lower. And I think in California, there's so much multifamily housing that sort of accounts for the lower rate there. But there are some states where it's, I think, more than 10% of the housing stock. And it's affordable ownership, which in the affordable housing world is a little unusual. Mostly affordable housing is about apartments. but even though they're low cost, we don't really consider them affordable, and it's not really a solution to the need for affordable housing. And these are the reasons why. The materials are often contribute to poor indoor environment. They decay rapidly because of the quality of the materials and because the HUD code is very weak. Not only is it outdated, but it's also just a weak code. So there's a lot of energy use, high energy use. The really old ones are at very high risk of fire. For a long time, I had like Google News alerts sending me, information, news stories about mobile and manufactured homes, and like 80% of them were about mobile home fires. It was so, distressing every morning to wake up to stories like that. And because they're such low quality, they decline in value as time goes on. You can see that, it's like problems develop. And so it's impossible to build equity in a home ownership situation with a mobile or manufactured home. And then of course, like they're oftentimes put in floodplains rather. They're vulnerable in case of tornadoes. So it's a bit of a liability to embrace this kind of affordable housing if you're in a situation where you really can't afford to repair and do the upkeep on a home. So our answer to that is replace, and do a replacement that results in true affordability. So our mobile home and manufactured home replacement effort is with zero energy modular construction. So you'll recall that modular construction is also built undercover in a factory, could be shipped, but it doesn't meet the same code, and it also doesn't have a permanent chassis underneath the home. And in the way that we define zero energy modular, the top priority is a healthy home. So we're looking at healthy finishes. There's an advanced ventilation system in all the homes, and the construction is really suitable for the climate. Here in Vermont, we've got 12-inch thick walls, triple pane windows. It's super duper airtight. In other climates, we're looking at a different particular specification in terms of energy efficiency, but still with the top priority being healthy, comfortable, appropriate to the climate, quality construction. We go all electric, so there's no fuel burned for anything. And
now, can I ask, Ling, just pause there for a second. I heard you say you have no specific certification you're trying to accomplish. Now, like I said, you guys are top-notch building scientists. You know better than some cookie-cutter certification. But that's also kind of a bold stand to make, because most people do go for certification of one sort or another, Passive House, Energy Stars, or So can you just speak to that thought for a moment?
Yeah, actually, I'm not sure what you heard that you thought I was saying about no certifications. The next slide addresses the certifications that we do. But I would also say that the level of construction that we're doing, or the level of, the efficiency specification that we're embracing, at least in Vermont, does exceed, pretty much any certification out there that we would pursue. The Passive House standard is it's like a long story about why we don't do that, and it mostly has to do with the limitations of the shape of the home. It's nearly impossible to meet, like just physically impossible to meet the Passive House standard. But putting that aside, like zero energy ready homes, we're there and exceeding it. So we'll talk about that in the next slide. Anyway, all electric, they go on foundations, permanent foundations. These things are not just like plopped onto, something that amounts to a sidewalk. And we do, at this point, we're using affordable housing funds to keep the cost down, so that people, we're aiming towards mobile home replacement for people that really need affordable housing. And over time, what we hope to do is rely less on the affordable housing fund. But we're redirecting affordable housing funds to an ownership situation rather than rental. Okay, so here we go. There's our specification, and this is for Vermont. It's a little bit different in some other climates that we're working in.
Haley,
super duper.
Peter's here as well, and he's just unmuted himself. So welcome, Peter, just so you know.
Thank you.
Hey, Peter. I think my microphone maybe isn't that great. Do you just want to jump right in and take over here?
Sure, perfect slide. So yeah, these are Efficiency Vermont certified high performance specifications, and our zero energy modular product meets this specification. So you can see the standards called out here. This is going to be variable if you were to move outside of the Northeast. We're in a pretty harsh environment. So to meet the demands of an all-electric home that often uses point source heating and cooling, we would need specifications that are close to these. So you can see, really thick thermal envelope, exceptional air tightness. Most of the homes in our program actually exceed the Passive House Energy Standard. So while you'll see the standards here, typically our homes will exceed these standards, particularly with air tightness. Triple glaze windows with insulated frames. We pretty much exclusively will put in casement and awning windows that use, closures that allow for air tightness as opposed to single or double hung windows, sliding windows. We'll do compression closure type windows, tilt and turns as well in some of the homes. Heat recovery or energy recovery ventilation. We also do some unique systems, which we'll show a little bit later on, which actually have internal exhaust air heat pumps. So the ventilation system also heats and dehumidifies and cools as part of the system. All Energy Star lights and appliances. EPA Indoor Air Plus, so our homes are delivered with quality materials that don't or minimize off-gassing. And then finally, WaterSense water fixtures. So really trying to reduce overall water usage, but also hot water usage to reduce energy demand.
Sean, did you want to know anything else about certifications?
So this is the result of one of our homes. You can see in the background, this is a classic mobile home park. Previously in this site was another older home that was sort of beyond its useful life. And this is an example of a zero energy modular. This home designed to not only fit on this existing footprint, a long, narrow footprint, in this case 14 feet by 70 feet, but it's also a home that was designed to travel down the road while being complete. So in the Northeast in general, specifically in Vermont, we're only allowed to travel down the road at 16 feet or less in width, and also at 13.5 feet in height. So when you include the trailer under the home, typically our homes have to be under 11 feet in height, because the trailers are typically about 2.5 feet off of the ground. So this is just an example of a home that can be delivered to accommodate this site and also travel down the road. And so, what Ling talked about, a little bit in regards to overall performance. I just want to show you the two bars on the left of your screen, the HUD home. That is a brand new HUD manufactured home in our climate. Burlington is not the most severe climate in Vermont, but it's a good average. And you can see the amount of fuel and electricity usage that home uses. In the middle is our zero energy modular home that meets that high performance specification that I outlined. And this is without solar. So we're comparing about 90 million BTUs per year on average, which would be about $300 a month, to a zero energy modular home. This one is just showing the energy usage without solar. That would be, as you can see, about a quarter of those costs per month. So let's say about $80 or so per month. And then on the far right is actually some energy usage data from our weatherization agency. So those are existing manufactured homes out there that they have audited. And you can see the actual existing homes when compared to that modeled new home. are actually using even more energy. And this is typically in our climate and in our region is going to be an unregulated fossil fuel. So kerosene and propane with electricity, and our electricity costs run about 18 cents per kilowatt hour. So you can see there's really great opportunity for savings. We can apply this methodology to, you know, a whole park. As you can see here, this used to be 14 mobile homes. In this case, the mobile home park owners had owned all of the homes that over time just were no longer habitable. So when our nonprofit partner acquired this park, it was 14 basically vacant, abandoned mobile homes. It was a real blighted site. And what they did, you can't see all of them, but there were in the place of the 14 single wide mobile homes, they put in 7 duplexes, all electric, all have these 6 kW solar systems you see on the roof, all have battery storage. This is a really unique low income rental community that one of our nonprofit partner owns and manages, and is a great example of how we can transition our mobile home parks into sustainable, affordable housing. Just some shots of what's offered on the inside. I already mentioned the Indoor Air Plus standard, so hard surface flooring, no VOC paints. We do ADA compatible or universal design units fairly regularly, as a good deal of our housing goes to folks that are elderly or downsizing on a fixed income, looking for adaptability as well. You can see the ADA compliant bathroom up at the top. Battery storage shown there on the right. We're pretty fortunate in Vermont. Our local utility has a residential battery storage program, so they cover the bulk of the cost to install batteries, well, both buy and install the batteries for our homeowners, and then you just sign on to allow them to have access remotely to those batteries, and they use those batteries for peak management. The homeowner benefits from having those batteries as backup power if the grid were to go down.
And in Peter, can you pause there? So that's a fascinating topic. It's been hot over here in California on the question of should batteries go in and how big. So how big is this battery? And more importantly, how many days are you expecting people to persist with this battery? And is the solar array islanded so that it can continue charging? So just could you answer a few questions like how does that battery work out?
Sure, absolutely. So the battery you're looking at there is an 8 kWh battery. The typical power outage in this area is 2 hours. This battery, worst case conditions, when we have the heat pump providing heating on a really cold day, and we have snow on our solar array, so we're not producing, and I'll answer your latter question in a second. We'll get about 6 to 8 hours of backup here running the critical loads. That would be the refrigerator, lights, ventilation, and heating or cooling with our cold climate heat pump. The battery can be charged by the solar, the Sonnen battery, as well as a Tesla Powerwall 2 and a number of other residential battery systems out there. They have an internal transfer switch. Grid goes down. They basically protect the grid from getting any power from your solar system, but the solar can charge your battery. So assuming the sun's out, you don't have snow on your panels, that solar can continue to charge your battery during a power outage and extend that battery life, possibly indefinitely. If you're really frugal with your energy usage and you're just keeping your house comfortable and ventilated and you're using your Energy Star LED lights, that battery could run for a long period of time. This is a Sonnen battery. This was part of a pilot, goes back a little over 3 years ago that we installed these units. They've been great. Really pleased with what they've provided both in battery backup, but also the peak load management for our local utility, Green Mountain Power, that we partnered with on this. They are now have a program where you can bring your own battery, and they'll actually pay you for access to that battery on a monthly basis. They also have a flat fee up front for a solar plus storage program right now, where you pay monthly to have. So there's no additional initial cost for getting into that program. You can just pay a monthly fee on your bill to have solar plus storage added to your home. And they have a pilot for commercial and industrial projects as well for both bring your own battery, where you get paid per month for having that battery accessible by the utility, or that they actually charge you per month if they provide that battery and the maintenance. So there's a lot there, like you said, to unpack, but there's just a quick overview.
Well, that's fascinating as a template for what could happen in California. So thank you.
Yeah, there's some great articles out there if you're interested. You could Google Green Mountain Power's battery storage as an example. They've done a good job of publicizing the benefits of their batteries, both for their peak load management, of which there have been really exceptional savings, reducing the expensive and often dirtier energy that they would have to otherwise buy if they weren't discharging all these batteries around the state. And the other one is we, for instance, just had a pretty severe weather event come through over Halloween of 2019, late 2019. There's a good article about the number of folks that benefited from battery backup during that time as a result of this program as well. So anyway, a lot of benefits there. So here we are swinging a home in. Traditional manufactured home delivery would be, back in on a trailer onto a slab, and you sort of jack up and level and plumb that home. With modular, you're picking it up off of the trailer, which you can see in front of that red car there, and you're swinging this home in and setting it down on some sort of frost-protected foundation connection to the ground. In our climate, we need to get down 4 feet or have a frost protected foundation of some sort. So in this case, we've got a 4-foot crawl space, and this home will be set on that. We can get down. You can kind of see just below the crane there, you can see an access into that crawl space. Our contractor can get down there, tie in all the utilities, but this home is literally ready to move into, if not that afternoon, the next day. So real turnkey product, which is what our home buyers need. We're typically displacing them from their existing mobile home for a period of time while we do the site work and get that home delivered, and try to keep that as short as possible. But in the underneath the home, the zero energy modular home floating, you can see that existing mobile home. And it's a real good example of what we see here in Vermont. You can see a secondary roof being built onto that home. As this is just what folks are doing to make ends meet here, keeping that home going by putting a roof on probably what is a failing roof on an older, probably 20 or 30-year-old home.
Sean, am I still unmuted?
You are. We can hear you.
Okay. So I also just wanted to point out about this one that you can see that the underside of the module is sealed, and that is so different from a manufactured home where you'll have lots of penetrations up into the home itself, and the ducts for the heating and cooling are typically under the home. So this to me is really the best view of like the defining difference in performance between the zero energy modular and typical manufactured home.
Yeah, that's huge. I mean, I'm from Wisconsin, and I just grew up with having like frozen feet because of basements and rafter, but there's just no insulation. This must be so much more comfortable. That's
it, yeah, and durable. The durability is critical. A lot of our homes right now, to reduce cost, we put on helical piers. And if folks aren't familiar with that technology, these are frost protected, structurally sound foundation for us in the Northeast, frost protected. And they're just piers that are auger driven into the ground. There's no excavation. We can go into mobile home parks where there's no room to excavate and stockpile material. We'd otherwise have to truck it off site. There's also a lot of parks where the utilities run directly under the home, water, sewer, electrical. So you can't excavate because you can't relocate those utilities. We can have DigSafe come in, use these auger-driven piers strategically placed around the perimeter of the home. Typically, they're about every 8 feet. This crawl space right here might run $16,000. We can do auger-driven piers, which are just as structurally sound as this full crawl space, for a third of that. So enough about the homes. I mean, I think, we have this slide here because it's really about these homeowners. Everybody you see here honestly did get out of, a real poor housing situation where their housing, like most homeowners, wasn't a benefit that that was helping them build equity and move up the ladder. Instead, it was a burden, often something that had high maintenance costs, energy costs, comfort issues, might have been resulting in poor health outcomes for family members. And we're getting them into the homes you see here, and this is what it's about. It's about not just celebrating home ownership, but celebrating, quality home ownership. And that's what we're trying to do here, is just sort of redefine affordable housing. It's not about first costs. It just isn't. And we need to be really considering the folks that we're putting into these homes, and not just think about, how much it is to get into that home. It's about that long-term picture for them. Can they, move out of poverty, or are we perpetuating poverty by putting them into a home that's going to be a burden on them, whether that's the asset value that's decreasing over time, like a typical manufactured home, or are we putting them into something that is going to allow them to build some equity and potentially move up? So, these are just some happy homeowners that we've served.
And I just want to add that we have a close collaboration with the USDA, and they provide low interest financing for income qualified buyers in our program.
Yep. Nice long terms, 30 plus years, and we're typically a point under the going mortgage rate. So Ling, I'll let you just introduce the Martells in this story.
Yeah, so we're gonna launch, this is the case study part of this case study. So this is a wonderful couple that we got to work with. They were living in a mobile home park for decades. They loved the neighborhood. They loved the location. Working family, both parents employed. They raised their family there. And over time, the kids grew up and moved away, but the parents stayed in the home, but it was just an old house. I mean, it was not a new house when they moved in, and they lived there for more than 20 years. And it was really getting to be quite stressful for them to live in that home. And through our flagship program in Vermont, we helped them move into a new zero energy modular. So if you'll bear with me, I'm going to switch over to a video of them. Is that working, Sean? Can you see the video?
Yeah, I can.
Oh, can you hear it? I didn't think about this part. I don't know if you can hear it.
We're all seeing it. We're watching you like drive into a snowy community right now.
Yeah, but there's music.
Oh.
What's going on here? Ah!
Well, do you have your volume on? Like if you go down to the microphone little symbol, you're to the left. Yeah, down there. Why don't you turn up the volume? See how the volume is not very high? No, other direction. Oh. Good. All the way.
No.
Okay.
Oh no.
And can you unmute your own computer, like turn up the volume, make sure that your volume on your computer is on? The master volume? Like on my keyboard, I have little volume buttons. And I've had this a couple times happen during this retreat where I've muted everybody on, anyway. Well, the point is, I think we can see that this is a nice family, that their house is a piece
They're
of
very nice. This is their old home. I don't know what else to say about it. Like, it was making, the house was making them sick. Anne was saying that she always felt poorly when she was in the house, and she had headaches.
Yeah.
Underneath the home. This is very typical for what you find under a mobile home. And through our program, as I said, they moved into a zero energy modular. Not only is everything new in there, but it's built with quality materials. And the little port that you see up there above the cabinet, that's the fresh air system. That's not delivering heat and cooling. That's delivering fresh air to every room in the house, and it's exhausting air out of the kitchen and the bathroom continuously. There's heat recovery, and in the summertime, it does some active cooling. So this is a home built not just with great quality materials and low VOC finishes, but also they're getting fresh air actively ventilating all the time.
And an easy clean off stove we can see. A lot of people, people get concerned about transitioning from gas stoves to electric stoves. One of the things they forget is that gas stoves suck for cleaning.
Yes,
they really do.
Good point.
Miserable. And
look at where their house is. It's just in a great place. And we hear this a lot from families, is like, they really do love the neighborhood. You know, not everybody has a view like that, but people like living, you know, close to neighbors. These guys in the video say that they are thrilled with that their house is high tech. You know, it's efficient. That's their ventilation system that John is showing you. You can see heat pump water heater tucked there on the side. Uses MERV 13 filters on the ventilation system.
That's hard to get good filtration. MERV 13 is great.
Yes, it's a high efficiency filter. Oh, if I had known, I would have tried to memorize everything that he was saying. I feel pretty lame about this. You can't hear what he's saying.
Don't worry about it. I mean,
he's saying he still loves his wife, basically, is why I called it "And Love in a New Home."
And a pretty flat solar array there.
It's very flat. So Peter didn't address that, but people oftentimes ask us about the structural integrity of the roof and why it's okay to just have snow sitting on the roof all the time. Maybe I should let you address that, Peter. I mean, why it's okay to let snow sit on the solar panels all the time.
Yeah, I mean, well, I'll speak specifically to the Northeast. We have systems like this installed on commercial buildings everywhere. It's not often, right, that you're coming across, although we're seeing more and more modern homes, I'll say, with flat or slightly pitched shed roofs. So I think this is becoming more common. But yeah, we are really relying on, in our climate, spring, summer, and fall solar production. And we design the systems to meet the what is the sort of estimated homeowners energy usage with the size of the system, considering that we're not relying on any production basically when we get into November through March. And that is because, you know, our sun is very low in the southern sky. We've got quite a bit of cloudiness during those, honestly, 6 months. We're living in it today. And then, of course, there's snow loading as well. And, you know, Ling, myself, we live with solar systems that are, you know, on the perfectly pitched roofs and facing solar south. You know, you can get some production in the winter, but even the ideal oriented and pitched roof still compromises production in our winters just due to less sun and snow load. So that's why, you know, you see the systems the way they are. It's also inexpensive to install those solar systems in the factory on an almost flat roof, and we can add additional modules at a very low cost. You know, we're under, you know, $1 a watt now in regards to our modules even lower. And so adding some additional modules, can make up for the less than ideal orientation and pitch. I'll also say that, we are running a mobile home replacement program. Unfortunately, our mobile home park developers weren't thinking about solar access or orientation of homes, getting homes set, with the long axis east to west and so on and so forth. So most of our sites that we're working with the homes are not oriented ideally. And so having a flat roof allows for us to have that house in any orientation and still be able to incorporate solar. And as I talked about with the battery storage and of course all the benefits of solar for our home buyers, we really want to incorporate it on every home that we can. And we do not have a real robust community solar opportunity in Vermont right now. And so really getting solar on your roof is the one way to really access renewable energy.
Good answer.
Here we are. This is the cost for the Martells specifically. You can see what their old mobile home was doing for them. And I'll just preface this by saying, they were not living comfortably. They were having health issues. They were just getting by. This is very common. We've done enough outreach and advocacy and hosted mobile home owners at our model homes that we know most folks, basically keep their houses at a comfort level they can afford. And there are months where, they are plugging in the electric space heater instead of buying that next tank of kerosene or propane that they actually need. Just to get through winter. So you see those energy costs. That's an average over several years while they were in that house. And their insurance and tax and lot rent and the total sort of cash flow on a monthly basis for them. On the right is their new home. And you can see their mortgage at the top there, the housing. That's with our USDA rural development financing. You can see the terms there. No energy. You could have heard them talk about the fact that they're building up a credit all spring, summer, and fall, and they're able to take advantage of that solar credit all winter to offset the energy usage when they otherwise would be paying electric bills. The taxes go up a little bit. The home is valued more. We do have a homestead tax exemption that's available to income qualified buyers that sort of protects our low-income home owners from excessive property taxes. So folks can take advantage of that if they qualify and choose to. But you can see while the total cash flow on a monthly basis is higher, there are so many benefits that they are experiencing for this additional $270, $280 a month. And, they're extremely happy with this decision. But this is something that we're continually working on with regards to trying to drive the cost down. We are working, currently with a partner on most of our homes, and they're building 30 to 35 homes per year, and we're competing in a market where we have, manufactured home builders that are doing, 5 homes per day. Literally, and taking advantage of those economies of scale. So, we're in this market transformation period. My hope is, within the next 5 years that, we expand on, the demand increases, of course, and that we can support a large factory like that and get a significant reduction in the cost per home because, economies of scale, we're just building that many more homes. To meet the demand in the Northeast specifically.
Our intention is always cash flow positive, and we are still in a struggle to find it. We're still looking for ways to drive the cost down and to reduce reliance on state incentives to make it accessible to low-income families. And I just want to point out that the benefits, so yeah, they're paying more every month. But some of the benefits are really like money related. So there's like no repairs that are needed in this home. And, based on the condition of the home that you saw in the video, mobile homes are typically not very repairable, but there were costs for them associated with the quality of their home. And they're also building up equity that they can now pass on to their kids, and they never had that opportunity before. There was no way that their living situation was going to benefit their kids in the end. They also are in a situation where they can age in place. And if you sort of consider what that old mobile home looked like and imagine them, 15 or 20 years from now, maybe with mobility issues like that just wasn't going to happen. So there are a lot of benefits to, that additional $200-300 a month that they're paying.
Yeah, and I'll just add, Li Ling speaking to, the individual benefits of these homeowners. From a societal standpoint, this is a whole nother discussion altogether, but a home like this going into an existing trailer park, most of our trailer parks, and if not all of them, are fairly stigmatized. They suffer from infrastructure issues, abandoned homes, obviously old homes that are beyond their useful life, that are in disrepair. Getting a house like this into these neighborhoods, it's amazing how it can turn around how people feel about their neighborhood, whether they're the homeowner in that new zero energy modular home or they're one of the neighbors. It's an investment in that community. And we have over 250 mobile home parks in Vermont. Li Ling shared with you, that's approximately 1 out of every 10 families in our state that are living in a mobile home. And, those neighborhoods are not going anywhere, but they are all in need of investment and they all need to be revitalized. And this is a great avenue it's sort of a catalyst is the way I see it. So I just want to note, significant societal values here, I think, for towns and just these neighborhoods in general.
And just since you talked about the societal benefits, I also want to point out that home will never need heating assistance again. So in states where there's a lot of money going towards heating assistance, this is a way to take pressure off of that budget.
Right. And
Yeah.
may I ask on the values, sorry to return to batteries, but in California, since we've started having planned power outages for fire safety, the power turns off for 2 to 3 days. And I wanted to know, those 8 kilowatt hour batteries, what did they cost to install, or what might they cost right now? Because people are definitely talking about putting in 5 kilowatt hour batteries, 8 kilowatt hour per apartment. What does that cost?
Yeah. Well, I'll just speak specifically to the Tesla Powerwall 2, which is the most, most often installed in Vermont as a result of a collaboration between our largest utility and Tesla. That battery, 12.5 kWh, I believe, the material costs about $7,000. And, depending on, but in a new home, you're talking a half a day installation for, an electrician or certified installer. So, not a big cost. And then, like I said, for when you start looking at the value to the utility, if they have access to it, it makes sense for them to cover that cost, to have access to that battery, to manage their peak load events. And they've proven that here in Vermont, and we're in a less opportune environment than, California, where you have far better sun, no snow load in a lot of the areas. And of course, with the power outages that you mentioned, certainly an additional benefit there in regards to knowing that, you can turn off the power, but they're going to immediately have this battery as a backup. And, assuming they're in an area where they're going to have sun that next morning, they can charge that battery and they can spend those 2 to 3 days on backup power as opposed to being offline.
Okay.
So generation and consumption, this is classic, Northeast in general. Here we are hardly producing, as I mentioned, over the winter. You can see what happens from October to November, but you can see how we're building up that credit basically starting in May. So those middle 6 months, we've got this credit that carries, in this case, these homeowners through the winter. We have the additional benefit in Vermont where we have a solar adder or PV tariff. So we're not only are our homeowners getting the full retail rate for every kilowatt hour that they produce, which will offset their usage, but then they get an additional 2 cents per kilowatt hour on top of that. So, you know, for that 8,000 kilowatt hours produced per year to cover your usage, you'll get, you know, another $160 towards your energy bill if you're not producing enough.
And on the battery topic, I think my mental math here is it's roughly $600 per kilowatt hour stored.
Yep.
Okay, that's a good price to work with for a moment. And just so you know, you guys are about 15 minutes over, but I wanted to give you enough time to.
Oh, sure. We're just about to wrap up, so we'll go through these last slides.
No worries.
Just a few slides.
For this one, I just want to point out that that home at probably 7,500 heating degree days is only using 5,600 kilowatt hours a year, all in.
Wow.
And that is less electricity than their other home was using, even though they were heating with kerosene in the other home.
Yeah. Yeah. Yep. So, you know, here you can see what we're up to here. We feel like, you know, this is a really great initiative, one that we'd like to expand, not only beyond, you know, Delaware, well, the Northeast and Delaware where we're currently working, but, you know, beyond. I think there's great application here, really great opportunity. Most of this housing stock that we're talking about, that is the mobile homes out there across the country, a high percentage of these are really beyond their useful life and are in need of replacement. So the big question is, what are we going to replace them with? If we're to meet the goals of our affordable housing partners and the challenges around our climate crisis, it certainly shouldn't be new manufactured homes. And as I'm sure Ling alluded to early on, even an Energy Star manufactured home, at least for us in the Northeast, doesn't come close to meeting even our bare minimum code for stick-built or modular housing. So that is not an answer. We've delivered 100 homes. We've been monitoring those. We're hoping to increase the production and delivery of these homes every year. We're putting them everywhere, whether it's in mobile home parks, private land. And so you can see the benefits here, just of this small initiative in Vermont, where we're sort of just getting going. But, you know, we're serving mostly low and moderate income home buyers and tenants through affordable housing partners and rental housing. And you can see that there. It's about a 50-50 split. You know, and we're going to start getting a better handle on, you know, the impacts of the health benefits. But you can see that, you know, our homes folks are living in have exceptional air quality. So just a few quick charts. This one just shows we're putting in a lot of our homes temperature, relative humidity, indoor air quality sensors throughout the home. This is just a good example of like how these homes with regards to comfort. Here we are, and you know, right now we're single digits in January. Just giving you an idea of how these homes can perform with just single point source cold climate heat pump. And you can just sort of see the crawl space just coasts right above freezing, so we don't have to worry about pipes freezing or even heat loss there. We've got all the rooms running fairly close together. These folks like to keep their home warmer. And you can see the mechanical room, which is often noted as a very small space for a heat pump water heater. But you can see with the way we set up our HVAC system, that heat pump water heater may bring that mechanical room down to 60 degrees, but it quickly recovers as a result of drawing in air from the adjacent spaces. And our heat pump water heaters are running very efficiently. So a nice system, just proves that. Indoor air quality, I noted that earlier. We monitor minute by minute air quality in all the homes. The main mechanical ventilation system that we use has built-in monitoring, which is really nice. So we can look at all different things, but this is just showing you we want to stay under 1,000 parts per million. You can see every ventilation event, which is highlighted by those green bars. Whenever the VOC or CO2 goes over that 1,000 parts per million. So the recommended high point that you'd want to have your CO2 or VOC at, the ventilation kicks in and quickly brings the air quality back below those levels. Some homes, CO2 drives the ventilation because there's high occupancy. In others, like this one, lower occupancy, but more cooking, and hence the VOCs drive ventilation. So it's really important. We have found, and this goes back almost 10 years, we've been evaluating this with demand control ventilation like this. We want to be looking at both VOC and CO2 to ensure optimal air quality. Relative humidity, real important in our climate. We want to keep the relative humidity down. We don't want to be upwards, over 40% during these really cold months. That can lead to condensation on your windows and comfort issues. So this just shows you how our RH can really be fluctuating outside up and down during our winter and heating season, but the proper ventilation system can really keep your relative humidity inside at the optimal level. And finally, these are just 4 random Vermont homes, which is one of our manufacturers, where we were looking at consumption, generation, and sort of the net of those two year to year. And with our solar adder, most of these homes have no to very low energy costs on a monthly basis. It's actually also really interesting to look at year to year. 2018 for us was a very cold year, and it was actually a very cloudy year as well. So our solar generation was lower and we had a higher energy demand, and you can see that in the resulting energy data. So it's just good for us to better understand how these homes operate year to year, than make assumptions based on just modeling. We really want to provide our homeowners with realistic expectations about everything about their home, whether that's comfort, indoor air quality, or energy usage. And so it's good to see that there's going to be some years where our homeowners may have some energy costs or higher energy costs than they've experienced in the past, but that, we may see the reverse of that the next year, depending on conditions.
That's the last slide.
Woo! Thank you very much, Peter and Ling.
Oh, thank you.
I really appreciate the battery details, by the way, because the two things that are unique about you guys is the intensely cold temperatures that you have to work with, which are replicated in California really only like in the Sierra Nevadas. Although
Yeah.
that's a lot of space, not a lot of people, but there's Sierra Nevadas are a big area of super duper deep snow and cold. So anyway, fabulously done. Thank you.